8 or 16-bit data to various locations. Different addressing modes of 8051. So in this class, we'll understand about the instructions related to arithmetic operations, so which are implemented in 8051 microcontroller. So there are totally, as you see, you have 8-bit. In this 8-bit microcontroller, all the operations are confined with 8-bit operation, and we can see we have instructions related to arithmetic operations. Say, for instance, you have addition, you have subtraction, you have apart from addition, subtraction, and multiplication, division, you have increment and decrement operation also. So this is going to increment by 1 or decrement. So that is going to be performed, which are again related to address manipulation and sometimes used for data. What you see is decimal adjust for accumulator. This decimal adjust for accumulator is kind of a special purpose instruction which is used for decimal number processing. So in this chapter we will have 5 operations. So the remaining 5 operations, that is your addition, so addition, multiplication, division, subtraction, apart from it, incrementing and DAA. So these are the operations that are related to the arithmetic operation in large. First, let us get into, today we will see about the addition operation. So with respect to this, the addition operation. Okay. So with respect to the addition, with respect to 2 mnemonics, one is add, another one is ADDC. So both are related to addition operation. So we have got 2 mnemonics for arithmetic addition operation. So both offer 4 addressing modes, like as you see, immediate, register direct addressing mode, and register indirect addressing mode. So they are both the instructions add and ADDC both offer all these 4 addressing modes. However, the difference is going to be the inclusion of carry. So in here, carry will be included. Here we are not bothered about the carry. So the first case, carry is not considered, while for the second one we are considered with carry flag for that matter during the time of addition. So therefore, multiple bytes of addition, when you go for multiple bytes of addition, then we could go for ADDC, where you have carry into account, or carry is going to play an important role. Okay, so we have 2 instruction related to arithmetic addition. So note that we have, in all the cases, the result would be available in the accumulator. Okay, with respect to arithmetic operation. So whatever you perform in the arithmetic logic unit, the result will be available in the accumulator, and the relatively be affected. Okay, so that is the point that you have to understand. So now we'll go to the add instruction, simple add instruction. I have typically 4 methods of using this add mnemonic with respect to 4 addressing modes. So first mode is add immediate with accumulator. So you will add whatever the value that you are immediately passed will be added with the contents of your accumulator. So that is your add immediate. Next is add a comma Rn. So Rn, as we have already understood, it takes value between 0 to 7. So add the contents of the specified register, the accumulator, and the result will be stored again in the accumulator. Okay, all the instructions in the arithmetic logic units, the result will be available in the accumulator by default. So next is direct. So whatever the contents that is indicated in this address, that is indicated in the address, this is the address location. So whatever the contents that is available or the value that is being available in this address will be added to the contents of the accumulator, and the result will be stored in the accumulator. Okay, this is in the way of direct addressing mode. So the last addressing mode where you are using this AND instruction is register indirect way. So in this, I will take value 0 or 1. So particular register, in the particular register bank, in the particular register, there will be an address memory location stored there. So it will go to that address that is being indicated by this register, and from the contents of that address will be added with the accumulator, and the result will be stored in the accumulator. So these are the 4 methods by which your AND instruction can be used in different address. Or an example here. So this example is like to visualize how the complete flow along with the data processing is going to happen. That we try to visualize. See, the problem is now you are asked to assume the memory location 04 and 05. Okay, which is going to contain. Okay, and we have to write a program in order to add these 2 numbers and store it in the memory location. Okay, in the memory location, what is the memory address is 30H. So now we are assuming that the register bank 0 is selected. Okay, so this is the problem. So what is that? Now the locations 0 and 05 becomes bank, since bank 0 is being selected, typically we are taking the value which is R4 is 04, and corresponding value of 05 is R5. Now these are the registers holding in the bank 0, okay, respectively. Now therefore, whatever we are trying to solve this problem via the 3 steps. So it requires only 3 steps in order to solve this problem. One is that we have to copy the one of the operand to the R4 register. The contents of this R4 in the accumulator, and then now add the accumulator and the content. Now when you add it, you will be having the result in the accumulator. Now you have to copy the result from the accumulator to the memory location 30. This is all that we have to do. Okay, so now what are the instructions for that? So to implement this, what we have to do is first we have to copy one of the operand. Say for instance, we copy the contents of R4, that is one of the operand, to the accumulator. So what we have to do, move the contents of R4, whatever is there in the R4 accumulator. Means that we are trying to copy one of the operand to the accumulator. Now when you are using this AND A, R5, which is register direct addressing mode, then you are trying to add the contents of R5 with contents of accumulator. Now the contents of accumulator is nothing but whatever the value that was in R4 is already copied to accumulator. Now the contents of the accumulator and the content of R5 is getting added. So this is the addition operation taking place at this instruction point. Okay. Now, upon this, what happens is that move the value from your accumulator to 30, which was asked in the question. We are asked to store the value or the result in the memory location 30. So the contents of the accumulator, that is the result of addition operation, is being stored to 30. So this is a simple program for the execution of ANDing instruction. Okay, let's see still further how the program memory and the data memory is getting affected. So now, we are understand how we are implementing it in the program memory and how it is happening in the data memory. First, in order to understand this functioning of the processor, we will consider the closer look via this understanding the memory and how each instruction is going to vary the program status word, all that we'll see. Okay, so now let's understand that we have loaded the program in the microcontroller, say for instance in the memory location. So this is the program that we have loaded. So this you have to understand with the help of your mnemonic opcode sheet. So all will have related opcodes. Say for instance, your addition operation is having the opcode 2D. Okay, so that is 2D is written here. Okay, so the instruction that is related to your move instruction was EC. So relatively you try to write your program there. Okay, so now what happens, you're trying to write your program from 01 FC. Okay, now you have loaded the code, the program memory. So that is your program memory, and the instruction starts from, say for instance, we are assuming that we have the instructions from 01 FC to 01 FF. Okay, now we'll try understand to assume that before the execution, this is the program memory location for the instructions, and you can see the data memory is also associated. So in this sense, we have understood that RS0 and RS1 is taking the value 0, in the sense bank 0 is being selected. Yes, in bank 0, we have the program like R04 and 05 are the memory location or the source memory location, so the operand location. So 04 and 05 we are loading the data values. So you have D, for example, being the values available in register 4 and register 5 of bank 0. Okay, now this is there in the data memory. So now upon the execution of the first instruction, what is first instruction? Contents of R4 to A. Okay, so now the contents of R4 is what? D7. So D7 has to be moved to the accumulator. Okay, now what happens is that upon the execution of that first instruction, which is move A comma R4, it is again, as you see, it is 1 byte instruction. Only it is going to occupy one memory, which is having the output EC. When you look into the program memory, you will understand that this is a 1 byte instruction. Move instruction is a 1 byte instruction and is holding only 1 byte in the program memory, which is EC. The mnemonics for move is EC. Okay, now execution of this instruction copies the contents of R4 of the bank 0 to the accumulator. So therefore, after the execution, accumulator will have the value D7. Okay, and since it is move operation is a data transfer, flags will be affected. That we have already seen. Okay, data move. And now you have to keep a track of your program counter, since 1 is 1. So at this stage, your program counter is incremented by 1. So it is go to the next memory location for fetching, that is 01 FD. So next instruction is add. It is, we are asking to add A comma R5. Instruction is going to be executed. So this add operation, if you see, it is again a 1 byte operation. Okay, that is the opcode for the instruction is 2D, which is present in the next memory location, that is your program counter, that is 01 FD. Okay, so 01 FD is now under operation. So now what happens is that the opcode 2D is going to take the content of R5. So we are supposed to add the contents of R5 with the value. Okay, what is the contents of R5? 9E is the content of R5. It is going to get added with the content producing. Okay, now the contents, so if you add 9E and D7, you will be getting a value 75. Just look at here. So when you add, this is the binary addition that is going to be performed. Now we have to understand that it is not coming with a carry. So condition, this is the status how it is happening in a basic AND operation. So when you perform it, the result is 7-5, and that 7-5 as a addition, it will be updated in the accumulator. So now this, if you understand now the program state or program status flags. So let's see how it is being affected. Note, now this is the understanding purpose we have elaborated here. We have to note that the carry out bit of bit 7. So this is your bit 7, carry out from the bit 7. 1 plus 1 will give you 10. So there is a carry over there. So the carry out of the bit 3, this 7th bit will be taken out as carry. So your carry flag is set. So when you perform the addition over here, the third bit 1 plus 1 is again, here again, when you're performing 1 plus 1, it is 10. So you have an auxiliary carry. So when you perform 3-bit addition, now you have 11, which is taken out. So you will have the auxiliary carry also being affected. Okay. So carry out of your bit 3 sets your auxiliary carry also. Okay. So now your auxiliary carry flag is also set. So because of this carry from bit 7, not from bit 6, so when you're, since there is a overflow, since 8 bits are only allowed, you have an extra bit that will be causing the overflow flag also to be set. Okay. So your overflow flag is also set. Result, you have odd number of ones in the accumulator. Okay, so when you have odd number of 1, then your parity flag is also have 4 flags being affected upon this addition operation. Okay, so now you got understood this point. So after addition operation, the numbers of accumulator is 5, and which is an odd number. So your parity flag is being set. So 4 flags typically are altered in the case of addition operation in this when you are executing the second instruction. Now let's see what happens during a third instruction, which is moving your contents of your accumulator to the point 30 into the address 30. So the third instruction is going to be move 30 accumulator to 30 address location. So this is going to perform the storing the result. So the data memory, what is the position that we have to store is 30. That is given here. So now this you have to understand, this move instruction over here, which is in direct addressing mode, is holding 2 bytes of instruction. So for your move it is F5, and for the address it is holding 1 memory location. So it's a 2-bit instruction. So your program counter will be incremented by 2. So now you have 30. In the location 30, the result in the accumulator is being stored. Okay. So now you can see the flags are being remaining as it is. So the opcode for it is F5, and the memory location is taking 30 value. Okay. Now the being move instruction, again you have to understand, there is none of the flags will get affected. Whatever the flags that are set will remain set. So your program status word remains unchanged after your next instruction, which is move instruction, is executed. So now the result which is there, which is 7-5 in the accumulator, is available in your data memory location, that is 30. Okay. So this is the execution or the inside the processor, how it is happening for an addition process. So this is a small instruction, a small program that you have written with respect to it. Okay. Next we have contrasting instruction, that is already we have as indicated, your ADDC instruction is taking into the consideration of your carry flag which is time of performing the 8-bit addition. So now we have already observed that the instruction add A, R5. So A, R5 would work if the accumulator is holding the value D7 and 9 in R4 and R5. So now we'll assume that this carry flag contains 0 before the execution. Upon this addition C operation, what happens is that there would be no difference in the result. The will remain the same, the result will be the same, but how your carry flag is set will change. Okay. So now let's understand this. So you have your, again, take this typical example of R5 and addition of your R5 contents with your accumulator. So we will have the same thing. Now what happens is that this addition is going to produce a value. So with the result, whatever you see here, with respect to your add, both the results will differ in the case. So the result one with add C will produce 7, 6, wherein your where your add will produce 7, 5. So note that the will be added with bit 0 in the case of add C, but you will have your carry flag being set with respect to your add. You will not have that 1 bit being added. Okay, that is the prime difference. Okay. So now we'll before getting into that, we'll see what are the different modes of ADDC can be presented. So here you have again immediate addressing mode. So wherein the contents of your accumulator is added with the value that is being given in the instruction with the carry. Okay, with carry in the sense, if you have an carry, it will be added to the 0th bit. So now your ADDCRN is again register direct mode. Whatever the value that is present in the register will be added to the accumulator and it will be stored in accumulator. And now again everything is happening with respect to inclusion of carry bits. Okay, now we'll have this again, we'll look into this with an example. So now we are asked to write a program to add two 16-bit numbers. So this is the 16-bit numbers we are trying to add. So the first 16 number is located in R2 location, and the next 16 we are choosing bank 0 is being used, and we are using the lower bytes are being used to store in the second 16-bit memory location is 09 and which is whose lower bit is 09 and OAS being the higher bit. Okay. Now this is the typically. Now we have to store the value result in the 2F and H0, the higher bits. Okay. This is the address that we have to store the typically our after your addition is being performed with carry. Now we have to store the result in this memory location. So now what we are trying to do? So we have one of the operands in R2 and the other operand is in R3. So now you are trying to copy one of the operands. Let's say we are copying the contents of R2 to accumulator. Then we are adding the accumulator content with 09. So whatever is there in 09, bits are available in 09. Okay, so lower bits are available in 09. So you have to add the accumulator content with your lower bytes. Okay, now store the result in the accumulator address 2F. Now we have to store the accumulator to the address 2F. So storing the result of the lower byte. Okay, now next you are copying the contents of R3 to the accumulator. Now you are adding with the carry. This is the point that you have to address. So next you have the second order higher bits available in 0A. Now you are adding stored in higher bits of your result place, that is 30. You have to understand this is not an 8-bit addition, this is a 16-bit addition. Okay, so we have typically 6 steps to be proceeded here. So when you look into this next, you will understand. So this is the code. So this addition, 16-bit addition with respect to your move and with respect to your addition and addition with carry. That alone we'll see. Okay. So now you have bank 0. So you have the as you have seen. So you have the value stored in B7C2. So first value is stored in B7C2. Then you have the second memory location. You have, this is the register bank, that is you are having the value 5499A is going to store second operand. Then the result is stored here. Okay. Now. Okay, so now what happens is that you have to take addition is with the contents of 09. Yes, we are talking about we have already moved the contents of your R2 to your accumulator. Your contents of R2 is being moved to the accumulator, and now that is your one LSB is moved to your accumulator. So that 8-bit is moved to your accumulator. Now you have to with the contents of the accumulator, and the result is stored in 2F. So lower bits of your result is stored in 2F. Now next what you have to do is take the contents of R3, that is your MSB, to the accumulator, and take OA, so which is holding the other operands. Then you are trying to add it with carry flag condition. So since you have 16-bit, you have a carry over here upon this. So that is also added here. So, and you are trying to save the result in 30, which is your MSB of your result. Okay, that is a higher order byte result value it is stored. So if you have a carry, then you are adding 1 plus it and it is stored here. Okay, this is typically an example of execution of addition using and your AND-C. Any doubts so far? So we'll understand about the subtract instruction, your multiplication, division, all in the later class. First, if your understanding about addition is good enough, then you can proceed in a very good manner. Yes, any doubts? Okay, fine. So in the next class, we'll we'll look on to the, once this is clear, we can get into instruction related to the arithmetic operations. Okay? Okay. If you have no doubts, we wind up the class.